Welcome back to the next video on new updates from Flutter Forward. Okay, Flutter 3.7 is live. You can check out the blog post as well as the release notes. Learning about improvements for web platform. Check out the customizing web app initialization, clearing flavors for Flutter, also known as build configuration in iOS international support. Nationalization support has been revamped and the internationalizing Flutter app page is updated. Okay, the DevTools memory debugging tool has been completely overhauled and the corresponding page using the memory view is rewritten. Writing and using fragment shader. Okay, let's see this. Like, I don't have any knowledge about shaders. This release include numerous. Okay, you can invoke a platform channel from any isolate, including background isolates. Yeah, we will go through this article as well, introducing a platform channel from any isolates, including background isolates. We have updated our Swift documentation. Swift to add Flutter screen, Flutter concurrency for Swift developers. Okay, maybe I will check that. Learning Dart as a Swift developer. Apple no longer support bitcode. Adding an iOS script target and Flutter FAQ are updated to app clip. Okay, iOS app clip target. I was not aware this was possible with Flutter, but nice to see. Code labs and workshops. Flutter 2 use of the existing that exposes a C API. They always talk about Dart FFI with C language. I wonder whether it is possible with C++ as well. Building a game with Flutter and Flame. Yeah, this could be very interesting. Like, once Impeller becomes popular, there could be which allows us to render 3D. There could be a chance that more game engines might come with the help of Flutter's Impeller. We only have Flame for now, and that is also only for 2D. Learn how to use Flutter emulator suite. Okay, so I think that's it for this. Both Dart and Swift support concurrent programming. This guide should help you understand how concurrency works in Dart, how it compares to Swift. With this understanding, you can create high-performing iOS app when developing it. Some tasks might take a lot. This includes fetching or processing large amounts. How a developer typically use Grand Central Dispatch to schedule tasks using shared thread pool with GCD developer are tasked to dispatch queues and GCD decides on which thread to execute them, but GCD spins up threads to handle remaining work, and this can end up large number of threads and the system can become overcommitted. With Swift, the structured concurrency model reduced the number of threads and context usage. Now each core has only one thread. Dart has a thread execution with support for isolates and event loop and asynchronous code. And isolate is Dart's implementation of lightweight thread. Unless you spawn and isolate, your Dart code runs in the main UI thread driven by an event loop. Flutter's event loop is equivalent to the in other words, the looper attached to the main thread. Dart single threaded model doesn't mean you are required to run blocking operation that instead use asynchronous feature that such as async await. Asynchronous both support async await. Async is a function that okay. This means that Dart VM could suspend the function if necessary. For more details on concurrency in Dart, leveraging the main threads operating system. The primary, also called as the main thread, is where the application begins running. Rendering the user interface always happens on the main thread. One difference between Swift and Dart is Swift might use different threads for different tasks, and Swift doesn't guarantee which thread is used. So when dispatching UI updates in Swift, you might need to ensure that works on the main thread. Say you want to write a function asynchronously and it displays the design GCD manually dispatch a process to the main thread. You might do something like the following. More recently, Swift introduces Actor to support synchronization for shared mutable state to ensure that work is performed on the main thread. Define a view model class that is marked as main actor with load function that internally calls an asynchronous function using task. Next, define the view model as a state object using state object with load function that can be called by the view model. That all works runs on the main isolate by default to implement the load function. Future builder. Leveraging a background thread slash isolate, Flutter apps can run variety of multi-core hardware, including devices running macOS and iOS. Improve the performance of the application. You must sometimes run tasks on different cores concurrently. This is especially important to avoid blocking UI rendering with long-running operations. Swift, you can leverage GCD to run tasks on global queues with different quality of services property. This includes the task property. In that, you can offload computation to a worker isolate, often called a background worker. A common scenario response. You can offload a computation to a worker isolate. Nice. Playful typography with Flutter. Flutter material 3 for Flutter. Flutter has segmented material 3. To add material 3 to your app, set the use material 3 flag to true in your themes constructor. Check out migrating a Flutter app to material 3. In theme data, new widgets, navigation bar and navigation drawer. Placed where navigation bar, segmented buttons, filled buttons, badges, generating a color scheme. get rubbish. Okay. It's been more than a year. Introducing background isolate channels. Now as a Flutter 3.7, the developer can use plugins from any isolate. This has been one of our deeper since it wasn't trivial to implement in their version work. Okay. However, Flutter has matured. It has increasingly focused on plugins from a background isolate. Well, it's clear that there is need. Why would someone execute code? The answer is sometimes you don't have a library might be calling invoking calls on a background isolate like the app might be doing significant component developer doesn't want to interfere with the UI. Virtual photo booth experience showcasing Flutter and machine learning. Okay, we will see this in the next video. Okay, thank you for watching. Bye.